Hi, and welcome to week 8, I believe. I just want to check that. I think it's week 8. Yeah, week 8 of Reproducible Research in R. This is a course being taught at LSU and also half online with lectures we released on YouTube, where you are viewing it now. And so in this course so far, during the first sort of 7 weeks, we've covered a lot of ground in terms of reproducible research, including the use of makefiles, the use of R as a statistical programming language, a bit on R Markdown and Markdown, Git and GitHub, and sort of versioning code and manuscripts and any product really. Apart from some things that are unversionable, obviously, like Microsoft DocX's and XLSX files, I don't think are properly versionable. But yeah, and so today we're going to be talking about R Markdown and LaTeX. And that's basically just a way to talk about different document preparation systems, go into a little more detail on R Markdown than we did when we first introduced it, and to talk about the nuance of developing different document formats, as well as stuff that you'll probably run into as issues when working with R Markdown. So things like working in citations and things like that. And so without further ado, I'll go ahead and share my screen and we can start sort of working through the notes. No. So good at now with this. There we go. All right. So similar to how I've sort of structured it before, in terms of the notes, I have now our studio screen on the right and my compiled PDF from my R Markdown lecture on the left. For people in the course at LSU, the reading that we'll be talking about this week is on R Markdown integrating a reproducible analysis tool into introductory statistics. And that's from Balmer et al. And so this, especially for the people taking this course at LSU, this is a timely lecture because they're going to present or turn in, I guess, final projects in just a few weeks. And so this is maybe important to start addressing concerns about the structure of the sort of final project, as the final project has to be completely reproducible from start to finish. R Markdown is a way to do that, to embed basically your text alongside of your data and code. Yeah, so at first paragraph, I just go into the background about R Markdown, which I've sort of already covered. R Markdown is incredibly useful, as we'll see throughout this lecture, in terms not only of making just simple documents, but also in making formatted CVs or resumes. It can be used for websites, books, research articles, presentations, because you can compile it to HTML or PDF. But I think the sort of strongest point, and one that I'll keep coming back to, is the idea of having a dynamic or living analysis where the R Markdown pulls in data that can change, and then so every time it's recompiled, the analysis has the potential to change depending on the raw data inputs. Sort of already went over that. One nice thing is that I believe we went over before in the R Markdown lecture, which we talked, I think, about in the same breath as we introduced R as a language, was the ability to insert other code blocks that are not R. So R is sort of the default, as I'm highlighting here in the RStudio window, but you can also insert bash, D3, which is a JavaScript library for interactive visualization, Python, R, CPP, so that's the interface between R and C++, SQL, or STAN, which is used for a lot of Bayesian stats. So yeah, it's a definitely really cool benefit. And there's probably others that you can insert as well. I'm not sure if that is an exhaustive list. So as I mentioned before, R Markdown, while I'm going to talk about it mainly in terms of these dynamic or living analyses, can actually do a lot of different things, including writing books, presentation slides, websites, et cetera, et cetera. And we'll go into how you can do this using R Markdown later. So yeah, so I sort of want to draw the parallel between R Markdown and LaTeX first, and then we'll go through and actually see we'll actually go through and process through some of the examples of how you do these different things in R Markdown. And R Markdown really, it does these things. It's able to be flexible because it stands on the shoulders of things like LaTeX, which is this document preparation language and system, and also things like Pandoc. And so that's universal document translators. I don't know how they build themselves, but it's this lovely utility that you can operate through command line. Let's see if they have a description of what it is. I don't know, they don't. But it's fantastic, sort of converting one document form to another. It's a good sort of conversion engine. And so I'll go into a little bit about sort of what is LaTeX. So LaTeX is a typesetting language that you basically use code, much like R Markdown, in order to generate a perfectly typeset document. And LaTeX normally compiles, or traditionally compiles to PDF, but you can also compile LaTeX to other things. The downside, the limitation is you can't embed code chunks. And so before R Markdown, there was Sweave. And Sweave was a way to basically insert R code into a LaTeX document sort of more directly. And then R Markdown is just a layer up in terms of removal from LaTeX, or at least like not directly acknowledging that it stands on the back of LaTeX. But yeah, I'm a huge fan of LaTeX in general. I write my manuscripts in LaTeX instead of using R Markdown, but I'm going to introduce you to sort of both, and then you can choose from there. I like LaTeX because I learned how to do it during grad school and have stuck with it because I think it provides you with more control over how to set things than R Markdown necessarily does. That being said, R Markdown is a bit better in terms of reproducibility. If you can load, if your data are small enough to where you can compile and rerun your analysis each time. So if you're only doing like a couple linear models on some decently small data, completely fine. If you're simulating large data, many analyses, then I mean, it becomes quickly just prohibitive to try to embed code and recompile it to a manuscript. So there's sort of trade-offs. Okay. So now we'll start with the assumption that we're going to write a document in R Markdown. And what I want to go into is a little more detail on the YAML header than I did previously. And so YAML stands for yet another markup language, as we've covered before. And it's structured in terms of R Markdown as separated out by these 3 dashes. And there's many different arguments that you can include in the YAML header. And so this is a very basic one here, which I think maybe what I introduced. Oh, sorry, I was using RStudio instead of the compiled PDF. And so this may be the one that I sort of introduced previously. as just a very simple, it's going to output an HTML document. It says it's 1942, I don't know why, and then provides a name and the title of the document. But this can be way more detailed. And what that's called when it's typically sort of more detailed, and how it relates to LaTeX, which is a different document preparation system, is that all the stuff that comes before that's in this YAML header is known as like the preamble. And so it's going to set things like your margins. It's going to point to a bibliography file. It's going to tell the engine that compiles it into a document what sort of format you want it in, HTML, PDF, etc. And so, yeah, R Markdown has its own defaults, allowing you to sort of get away with using just something simple like this, so sort of a 4-argument YAML file. But it allows you the flexibility to include other things. And so, whereas here, this last line, I'll scroll up in the R Markdown, this last line is output to HTML document, we could have all of this. So I'll go sort of line by line. And what this is saying is, instead of the output being HTML, I want the output to be a PDF document. And here are the different things that I want to hand to LaTeX, basically. No, there are arguments that I want to be true. So it's going to use NatBib as the citation manager package. And so rendering citations within R Markdown or through LaTeX is possible with the help of many different citation packages, but the main one is NatBib. And then it has these Boolean arguments where it says, should I keep the raw text? So it's going to go from, the code, the R Markdown code does not go directly from R Markdown to PDF as sort of you would think it would if you just looked at what you had in your folder after you compiled the PDF. It goes through text first. And so keep text as like, should I keep the intermediate file that is a LaTeX file, and that ends in .tex. This says, should we include figure captions? This is the LaTeX engine. I'm not going to go into that, but it doesn't matter. It does matter, but it's not something that we need to talk about. And then also this, which is a really nice feature of R Markdown, and it allows you to include basically tech code as your own independent preamble. So much like R, LaTeX can use different packages. So like if you have a table that you want to turn sideways, there's many things that you could use a package for. Certain fonts or sort of require a package or require an argument to a big package called font spec. And so that can be specified in this template folder. And then it has some things that are conserved in that original 4-line YAML. So we still have title, everything like author. And what I'm doing here is I'm separating out, there we go, separating out author by name and affiliation. And that's probably something that is handled within this template file. I don't think it does it by default, but I'm not sure on that actually. And then here I specify the date actually using inline R code. And so what this does, if we run it, oops, go to console. Let's just copy and paste this down into our console. It gives today's date, which today is July 28th, 2020, in this format. And so when you want to do inline R code, you just do a single tick and then specify the language, which is R. Geometry is a LaTeX package, so use package geometry that sets the margin. You can play with the margins, so it gives you complete control. And it's not just about setting like one argument margin. You can set every single aspect of the margin: inner margin, inner, outer, left side, right side, top, bottom, etc. And then we give information on what font family we want to use, information on font size, information on spacing. And so that would use the line number or line no package. And then information on what bibliography file you use, as well as the style file. And so the bibliography file is a .bib file, and we'll go over more detail about that in a bit, but I just want to go over high-level stuff. So this is a separate file that contains entries of bibliography, contains bibliography entries in a certain format. And that certain format can be found by going to Google Scholar. So I'm going to drag my window over here. So if you search for ecology in Google Scholar, and you click the Cite button, you can click on BibTeX, which hopefully you can see. I'll zoom in here. And so you can see this is a book by Eugene Odom called Fundamentals of Ecology. Not just Eugene Odom, but also Gary Barrett. You can click on BibTeX, and this is what a BibTeX entry looks like. I'll zoom in again, and you see it has, they all have this format where it's at and the type of thing, article, etc. Some sort of key, which I'll talk about in a little bit. And it's just a sort of unique identifier. And then a bunch of information about the book or article or work, and then a closing bracket. So I'll close that. I think I accidentally tried to run something there, and it was not happy about it. Oh, and that's, okay, so apart from the template, so above I give an example where we say, what template should we use for formatting? And that basically provides a bunch of tech code that is going to be in a header that will give information on the structure of the document, the structure of the outputting PDF document. We can also just mash all of that tech into something, all that tech code into something in the preamble, which we say includes, and then in header, which means before you start the document officially. So it's going to be a bunch of code, and then begin document is going to be down there, and that sets up the environment. And so this says put this preamble before you begin the actual document. And so it's all the preamble is not going to be rendered to PDF, right? It's not going to show all of this sort of YAML header stuff in the compiled document. It's just telling how to make the document. So in terms of LaTeX, the code is going to look a little bit different than what many people are used to, but you may see some sort of similarities between what we saw in the YAML header and what LaTeX is doing in the background or underlying this sort of simple YAML code. And so when we include the preamble.txt in the header, our preamble could call in a bunch of packages that are useful in LaTeX. So for instance, we need the geometry package in order to set the page dimensions. And then we can set things like the size of the paper. We're going to need the natbib package, right? We said citation package is going to be natbib, and so we need to import that in order to use it, much like you would import libraries in R. Graphic X is used for incorporating figures and graphics into LaTeX documents. That's that font enc package for font encoding. And then you have things that just use like symbols, so math symbols, other symbols. This is a package for line numbers. This is a package that controls spacing. And so this is just a basic set of packages that you would probably use. Yeah, and so this may look very confusing, but really in terms of LaTeX code, it mainly boils down to the preamble as arguably the most confusing part. And then once you're actually writing it, much like R Markdown, it just sort of looks like text. There's not that much in terms of actual formatting. But there are some differences, but we'll go over them. Unless I just decided not to talk about LaTeX that much, which sounds like me, to be honest. Because I use it and I like it, but I also recognize that it's a whole sort of beast unto itself. So we introduced code chunks into when we were talking about R Markdown, and you've sort of seen them as I've gone along with my lecture notes, how I've sketched them out. And code chunks have these 3 backticks, and then they separate their curly bracket, and then they specify the language, and then they have arguments that are associated with them, which is really, really helpful. And so you may have seen some of these before. I'm not sure if I've called attention to them, but things like setting eval equal to false, which means when you compile this, don't actually evaluate that statement. So don't actually run the code that is within the block. You can also use things like echo. So echo, which I put right here, is saying, should we print any of the code or not the output, should we print the code to the screen? Because it will print the output, but it doesn't necessarily have to print the code itself. And we can set some of these chunk options, as they're called, so code chunk options, by using this syntax where we say ops_chunk, the $, the set function here, and then we set a bunch of things that are conserved across code chunks. And so this would probably be somewhere high up in your document where you set these sort of default parameters. And you can always change these by specifying in the code chunk, I actually want this fig width to be 3 instead. But here it's going to set the default width to 8, the height to 5. It's going to default to echo equals true. It's going to suppress warnings or not give warnings. It's going to cache the code with the results of the code. And there's a bunch of things, like there's many, many chunk options, which I just don't go over here. And so you can see more of them in Advanced R, which is Havi's book, or probably just in sort of the, what is it? Yeah, so just hit tab and you can see all of the different ones. Yeah. And so things like fig caption, where the figure should be aligned. Yeah, there's many, 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 many sort of options to play with. All right. Okay, so now I'm going to sort of go back for a little bit of citations in R Markdown. And so R Markdown, like for everything, it's using LaTeX as a backbone. And so how you do citations in LaTeX is something like this. So if I wanted to cite a Dallas 2020 paper, it would be \cite P in that bib format to make an end-of-line citation or an in-text citation with cite T. Okay, so why this is useful. Once I type this into my document or do any sort of dynamic citations in R Markdown or LaTeX, when I compile it, I don't have to worry about my bibliography because it's going to format everything for me. I hand it my bibliography, these commands, and then a style file, and it does everything for me. And so I know like Mendeley and Zotero and EndNote have probably come a long way, but they're not touching this level in terms of ease of use, I don't think, in my opinion. But let's focus on how citations are done in R Markdown. And so here I set a code chunk where I say citations in Markdown or R Markdown are relatively straightforward. And then here's the structure of the syntax. So it's open square bracket, the ampersand or the @ sign, and then that key. And so what this looks like in terms of bibtech code, because so R Markdown is going to pull from a bib file, and this bib file is a separate file that you make and that you put all these citations in. You can put more than it's going to need, and it won't get angry, right? So you could have like every citation in the world in your bib file, and it's only going to pull what it needs from that. So whatever you call it will use to format the bibliography. And what this bib entry will look like is this. And so we went over this with a book, but now this one's an article. and this is the tag. And so I use this tag up above right here. And so this R Markdown document is going to look into that bib document and try to find something with this tag, and then it's going to format it as citation. So it has information about journal title, or sorry, article title, author list, journal, volume, blah, 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 blah. And then we can see how it's actually rendered. And so here, it doesn't render it because it's within a code block, but then I use it here, the citation, for example, the citation above refers to the bib entry below. And here we zoom in, and it cites it. It renders it differently. And it may even have it has a bibliography at the end where it shows that's the citation. All right. So now I'm going to go over a little bit about formatting some of like your analytical output. And so that'll be figures and tables, or tables first. So here we're just going to make an example table. And so here we have this tab data frame that I just made. And it has a column called variable, a column called T, a column called P, and each one corresponds to a different variable: temperature, precipitation, and ice cream. So knitter, which you use to knit documents to PDF, so that's the reason why this button here exists in RStudio, has a function called cable, which outputs tables in a very simple way in the format that Markdown accepts tables. And what this looks like is, it rendered it for me. Just give me the raw output. Oh, how do I? Okay, yeah, let's just insert it down here then. All right, so that is what it's actually going to output. RStudio is putting its own little pretty text spin on it, but this is what a Markdown table looks like. And this is what it's going to output. And then once it compiles into PDF, this is what it's actually going to look like, is this either one. So it's outputting both tables. Oh, because I'm saying, wait, why is it doing that? Oh, whatever. I think it's because I have eval and echo as true. No, that should be fine. I actually don't know why there's two of them there. I feel like there should only be one of them. Oh, there we go. Okay, so I recompiled the document and now there's only one. So that must have just been a bug from before. So I apologize for that. I must have copied and pasted the Markdown formatted table down here before. Not like that. Regardless, so that's one way to get tables in, and then you can add like your code chunks and say something like, is it a table caption? No. I guess do fig caption. There's probably a way to caption a table better than that, but I'm not aware of it. And I want to make sure that I draw the sort of parallel from R Markdown to LaTeX, and LaTeX does tables differently. And so LaTeX code, you can insert LaTeX tables using Xtable. I think there's probably other packages in R that will format a table for you. And so this is a package in R called Xtable, where you run it like that, and it actually outputs it in LaTeX code. So in LaTeX code, this may look really like ugly when you first look at it, but actually, I think it's really nice. And that you specify everything. So this is like begin table, and this tells, this indicates where the table should be. So this is saying here at the top of the document is where it's supposed to compile to. Centering means like center the table, and then begin table, begin tabular, sets up a tabular environment. And then you specify the columns and where you want the alignment of the columns. And so here it's just sort of assumed that it looks like this uses the first column is left aligned, and then I can't really tell the other two. These headings almost look like they're right aligned. So that's kind of odd, right? Like, what if I don't want that? And so here I like specifically set every single, I have more detail, I have more fine scale control. And so that H line just draws a horizontal line like this. And so in our Markdown version, it would just be that dashed line that we can see if we run the knitter. Oh yeah, and you actually do, so that separate, yeah, so that is left aligned. That's how you designate left aligned with that colon there. And that's how you, if it's on the right side, then it's right aligned. If it's on the left side, it's left aligned. I think if you put it on both start and end of the dashes, it becomes center aligned. I'm not sure about that. I don't use it that much. So yeah, these are two different ways to do tables. I wanted to introduce the LaTeX code just to get you more familiar with LaTeX, but I'm not going to really go into that much detail about LaTeX. Let me know if you would like me to go into more detail, and I'm happy to sort of walk through a more detailed explanation or exploration of LaTeX. So next, figures. And so that's where sort of LaTeX and R Markdown are fundamentally different, especially because, so if I rendered a table using xtable in an R environment, I'd then have to copy it over into the LaTeX file that is like my manuscript or my working document. Whereas rendering a table in an R Markdown document, I just get, it's more dynamic and it's just embedded into the actual output, which is nice. Figures are the same way. And so here I set up a code chunk where this is going to be plotted, and it's going to plot, it's going to show this code that was used for plotting. So this is just plotting a vector of 1 to 10 by 10 random, draws from a uniform distribution. It's going to use a PCH of 16, which means a solid point. And then its type equals B, which means it's going to both draw points and lines connecting points. And it renders. And so there is that plot rendered. We can also include graphics, which we generated from another time that we're not generating on the fly, but that we generated and saved to like PDF or another format using this knitter and include graphics function, and then we just hand it the path to the file relative to the path of the working directory, which is wherever this R Markdown lives. All right, so figures, and then we can include things like figure captions and things like that, and specify different things about figure width. So fig has all of these things, which control how the figures output, what it looks like, et cetera, et cetera. Let's collapse that. All right, so equations are really nice to do in LaTeX, and you can enter a LaTeX environment when you're writing R Markdown code by using the double $sign to get into math mode. And so this is how you would format equations in LaTeX, which is really nice because if any of you have tried to format equations in like Microsoft Word, it's not super duper fun. So yeah, there's that. And so here what I'm doing is I'm showing the actual code itself, and then I'm writing the code as it would appear. And then you see in the compiled PDF that it shows the code to make it, and then what the actual output is, which is this summation of, for I equals 1, for all n, x sub I. And I mean, learning this sort of syntax of how to write in math mode takes a little bit, but not really all that long, to be honest. It follows pretty much standard LaTeX format. So \sum is the summation, underscore is subscript, square brackets curly brackets are used to sort of separate either arguments to like call a function. And so like, that's how you'd make something bold text. And we can use an example of this, of implementing this in our Markdown. So that's just calling LaTeX. And let's see what it looks like when it's knit. It might do something weird with like centering it or something. Yeah. All right, so now we talk a little bit about figure and table referencing, or equation referencing as well. And so this is a way to call in-text things, like say, oh, see figure 1, and have figure 1 be sort of separate. And so we can label figures when we set up the R environment, or when we set up the R chunk. So here I call this fig 1. Yeah, and there's other figure things that you can say. And then you can, so here I tried to use a LaTeX reference. So this is how LaTeX would reference things, would be \ref. They said they would reference it like that. So \@ref, open parentheses. But when I try it either way, it doesn't actually work. And so I actually don't know what the problem is there, but I'll try to like get to the bottom of that and get back to you, at least for the students in the class. People watching on YouTube, correct me, because I'm sure some of you know how to do that. And then one thing I would also mention is this is LaTeX code for the equation that you can just insert as begin equation. So you actually don't need to enter math mode using the $. As long as you're compiling to PDF, you can hand it things like this. So I'll just keep that in the notes and recompile the notes. There. All right, and so now we're going to do a little bit about the templating of R Markdown that can allow you to do some fun stuff. Okay, oh, and this is the plot from down here. And it comes with a figure caption. And so I made the fig.cap argument figure caption, and now it labels as figure 1 and gives the figure caption. Okay, so we'll switch gears, and now I'll talk a little bit about different sort of R Markdown formats and how to use them. Sorry about the little break there. I had a meeting to run to, so I'm recording this in parts. But this last part is just going to wrap up some ideas around sort of what you can do with R Markdown, specifically by pulling in the sort of cool aspects of templating. So I will share my screen. So this is where we left off, is right at the end where I'm talking about templating. So now we can actually close this and just have the RStudio document, and I'll show you how you can make your own templates or use existing templates for documents in RStudio. And before I go any further, I would like to point out this great resource. If you can see that text, I'll copy it over here so it looks bigger. So RMD for sci.nj Tierney. So that's from Nicholas Tierney, and it's a book down project about the use of R Markdown. And so book down is a add-on package that allows you to write books using R Markdown that have nice sort of templating, as I'm showing on the left there, in terms of table of contents and boxes of colors and different sort of formatting. So I'm going to close that. erase that, and now I can show you some of the templating. And so how you go about it in our studio is you click on this new document, and you click on R Markdown, and then it allows you to choose whether you want to do a normal document in one of these formats, a presentation, and so there's different frameworks for presentations. Beamer is the LaTeX sort of traditional presentation, and then these will output as PDF, and then these two top ones will output as HTML presentations, which some people argue is sort of prettier in terms of its transitions and its allowing of embedded movies and GIFs and things like that, whereas you can't really embed movies or GIFs that successfully in PDF. So there are like workarounds. It also allows you to do sort of Shiny apps. So Shiny is a way to make interactive graphics and documents, sort of having some sort of control from the end user, and then there's hosted server side typically by the Shiny apps IO people or other places you can self-host. But what we're going to focus on is writing sort of academic research articles or something like that from these templates. And so R Markdown only comes with two templates, GitHub doc and package vignette. And these are cool, but I think what's sort of more interesting, not more interesting, but maybe more useful for academics is formatting manuscripts for publication, which is a center view. And so these are within the articles package, sort of listed there, the mouse is. These contain formatting for many journals that I think a lot of us would be submitting to, sort of across the sort of academic spectrum. So they're pretty standard, like Elsevier style journal article or Frontiers style journal article, as well as more specific journals like PLOS, PNAS, Journal of Statistical Software, etc. Royal Society, or Royal Statistical Society, and Royal Society, Open Science. So let's say we're going to submit to PNAS. Let's not submit to PNAS. Maybe a little problematic as of late. Let's say we're going to submit to Elsevier, which they also tend to be problematic in some ways. Their profit margins, gouging, subscription costs. I don't know what's called this project. Why we charge so much? Question mark. Oh no, I messed up. Ooh. From template. And now it's not even listed as an option. Am I going? I might be crazy. Well, let's just choose another one. We've angered let's choose Royal Society Open Science. We'll just call this one example. All right, that actually ran. It says that Bookdown is required but not installed, so let's go ahead and install that. And what we see here is that, oh, it's really long. This is all part of the YAML header. So as I'm still scrolling, and there is the end of the YAML header. And I think why it's so long is because that's doing the majority of the work in terms of the upfront formatting of author affiliations, author addresses, corresponding email, the keywords, subject, abstract, all the things that you would put into an article that deal with accessibility, so accessibility of data, author contributions, conflicts of interest, things like that, are just put up front in the YAML header. And then we see the sort of standard Markdown format, which is really nice. Shows lines, gives examples of lists. That's how you would cite for LaTeX, and so it's actually just using base LaTeX citations instead of using the citations that we saw that look like that look like actual sort of R Markdown or Markdown flavored citations. And then here's where it just gets good. So here we have the embedding of the analysis code into the output. And we can knit this. Nice. So we knit that to PDF, and now we have this really nicely formatted document. And so this is from Alice Anonymous and Bob Security, which we can edit that up top here. And we have something that we can pretty much like straight away submit to this journal, and then it'll go into review, hopefully, looking in a nicely formatted way, which will speed up the scientific process, is the sort of overall idea. So let's close that actually, and now let's see the example they give for the HTML presentations, because they're actually also sort of really fun. And they really don't differ that much from how you'd approach writing a normal document. And so here you see that the YAML is actually really small, which is surprising because it doesn't have information like author. So if I put in author, I'm not even sure if it'll work. Let's find out. And this is the output as IO presentation, or IO slides.post underscore presentation, instead of like PDF document or something like that. Here we separate slides via these callouts. And so each slide starts with a secondary header, or a heading 2. This is agnostic to spacing, so we can just add spacing in if we want to. I tend to like more spacing than I guess is necessary. So let's knit this. Save it as presentation.rmd. And now it's knitting, and it's opening within the RMD. I want to open it in a browser because I think it's really ugly when it tries to mash it through RStudio. All right, so I'm going to close that, and I just opened it in the other window, so I'll pull that over, copy it, and now we have a presentation. And it did accept the author field, so it has author here, and this is my presentation that you can open up with any internet browser, and it renders as HTML. And you see the transitions are just a little more fluid. And this is a way to really easily embed our code directly into your presentation, which I think is really cool. And then there's tons of other applications in terms of just like building your own website. That's a little bit clunkier in my opinion, because how often will you actually need to embed our code into your website? I think it's maybe better just to use a static site generator like Hugo or Jekyll and just write in Markdown code and then do the liquid templating on the back end. But that is a conversation for another day. That doesn't really have to do with reproducible research. And with that, thank you for your time and attention. And I hope this has been informative. So take care.